So today's webinar is based on an appropriate subject, taking consideration into the present scenario. Green chemistry may be a new word for me, a man who belongs to arts department. Green chemistry, which was established about 2 decades ago, has attracted much attention. It reflects the efforts of academia and industry to address the challenges related to sustainable development of the chemical industry, and continuous progress is being made both in academia and industry. Briefly, green chemistry is the utilization of a set of principles to reduce and eliminate the use or generation of hazardous substances in the design, manufacture, and applications of chemical products. Green chemistry is a multidisciplinary field and covers areas such as synthesis, solvents, catalysts, raw materials, products, and efficient processes. Green chemistry will be one of the most important fields in the future. Although this field has developed rapidly in the last 20 years, it is still at an early stage. Promoting green chemistry is a long-term task, and many challenging scientific and technological issues need to resolve. There are related to chemistry, material science, engineering, environmental science, physics, and biology. Scientists and engineers and industrials should work together to promote the development of this field. There is no doubt that the development and implementation of green chemistry will contribute greatly to the sustainable development of our society. Thanking you all.
So this is my proud privilege to introduce Professor R.K. De, a Department of Chemistry, Central University of Jharakanda, Ranchi, to the August gathering. Dr. De was the pioneer in modern research, especially in the field of polymer science, nanotechnology, and green chemistry, which is the emerging sustainable field of research nowadays. Professor R.K. De is a renowned researcher and published many papers in national and international journals to his credit. As Professor R.K. De is the most vibrant, senior-most teacher of Central University of Jharkhand. So recently, he was VC acting of the prestigious university so far. Dr. De has produced so many research scholars, and they are awarded with a PhD degree under his guidance. So with these sweet introductory remark, I wind up my introductory speech over our Chief Resource Person, Professor Dr. Ratan Kumar De. Now I request our head of the department, Dr. Dushasan Parida, to give a brief keynote address on the subject matter, that is green chemistry. Dr. Parida.
Thank you, Dr. Pradhan. Thank you for your kind coordination with the our guest, Professor Dr. R.K. De. Good morning to all of you. The respected Professor Ratan Kumar De, Head and Professor, Department of Chemistry, Jharkhand University, Central University, Jharkhand. Honorable Principal of this institution, Professor Prabhakar Raut sir, Co-Convener, Dr. F.C. Fakir Chandra Pradhan, IQAC Coordinator and Associate Professor of Chemistry, Dr. Sunil Kumar Pradhan, another member of this department, Dr. Professor Ranjan Kumar Gahan, and my all the respected participants, dear students of this institution, as well as different institutions of Odisha as well as India. Actually, I am very much grateful to our resource person who has given his consent to join us to give a brief idea about the application of green chemistry, why and how it helps us and as well as in universe to recoup different chemical tragedies of previous and present era. He has chosen a very focused area, recent advances in green chemistry. Actually, the term green chemistry was born early 1990, but it is recognized in 1993 by Paul T. Avastas of United States. Now, which took a great role in the development of our society, as we are surrounded by so many chemicals, so many chemical effluents from different chemical industries, plastic wastes, as well as different chemical hazards used in the agrochemicals. So it is necessary to come out from the chemicals and to use such materials which is environment friendly, as well as help in every respect to save the society, to save the environment. That is why I appreciate the subject chosen by our respected and esteemed guest, Professor De, and I will request him to give a very brief idea about the application for which we will be, by our society and our student will be helpful for the society to improve their activities to save the nation, to save the environment, to save the world. Thank you, Dr. F.C. Pradhan, for your recommendation for the brief idea about green chemistry, keynote address of the green chemistry.
Okay, thank you, sir. So, green chemistry is a relatively new emerging field that strives to work at the molecular level to achieve sustainability. The field has received widespread interest. The field has received widespread interest in the past decade due to its ability to harness chemical innovations to meet environmental and economical goals simultaneously. Green chemistry has a framework of a cohesive set of 12 principles, which will be highlighted by our brief episode. Point one, I request our resource person, Professor R.K. De, to start this webinar. So, Professor De.
Okay, thank you. Am I audible? Am I audible to all of you? Dr. Fakir, am I audible?
Yes, sir.
Okay. There may be this internet problem always remains there. Okay. So should I start, Dr. Fakir?
Yes, sir.
So thanks to Honorable Principal Sir, Professor Prabhakar Raut. Thanks to the head of the Department of Chemistry, Dr. Corida, and an IQAC coordinator is also present here, Dr. Sunil Kumar Pradhan, my friend, Dr. Fakir Charan Pradhan, all the faculty members of the Department of Chemistry, students who present in this webinar. Thanks to all of you for kindly inviting me to say a few words on the aim of this IQAC, the national webinar organized by the IQAC cell and also the Department of Chemistry, Pattamundai College. Today is a very nice day for us because today is also the International Women's Day, and I can see a lot of faculty members, lady faculty members, as well as the girls students are also present. My sincere gratitude to all of them on the eve of International Women's Day. On behalf of chemistry fraternity, and I got an opportunity to say a few words regarding the green chemistry, and as the head of the department and the co-convener Dr. F.C. Pradhan, as well as the honorable principal sir has told, the green chemistry carries an importance in today's life. Chemistry as such is a very important branch of science. I'll start my slides, so just give me 1 minute after all. So chemistry itself plays a very pivotal role in every aspect of life. Very primitive science, very primitive branch of science, developed slowly. And today, we cannot think anything without chemistry, be it any branch of science, be it any branch of engineering, be it any branch of even social science and humanities. Everywhere chemistry plays a role. Knowingly, unknowingly, directly, indirectly, whatever the case may be. Right from the living organism, the human being itself is a chemistry. The complex molecules that form this human being. You can see that if you see the nature, nature beautifully designed everything. Each and everything beautifully designed in nature. Very particular manner, very scientific way. So what happens when we are doing research, our guide tells us, mimic the nature. Mimic the nature. I'll give you some examples of how we mimic the nature. In my experiment also, I tell you a few experiments that I have done in the field of green chemistry. Green chemistry is a quite vast field. May not be possible to cover everything with a span of 30 minutes or 45 minutes or 1 hour. But surely I'll try to create an interest among the young faculty members and our students to pursue a career in this particular field of study. So let's start with this slide. So whether slide is visible to you, Dr. Fakir?
No, sir.
Yes. Is it visible to you, Dr. Fakir? Or should I have to upload it? Okay. Just I have to upload it, I think. I hope. Share screen. Now is it visible?
Yes, sir.
So whether I have to make it a full screen or is it okay?
Sure.
Please check.
Sir, make it full screen.
Is it okay now?
Yes, sir. Yes.
Okay. So let's start with little bit idea about the green chemistry. I must say that what Dr. FC Pradhan has told, the principal sir has told regarding me, regarding green chemistry. I know very little about green chemistry. I don't know many things. I must admit from the beginning. But whatever I did, whatever research I did, I maybe give little bit of glimpse of the green chemistry in it, what I have did, what I have did in my research, and some basic principle of green chemistry and how you can apply it in our chemistry laboratory. That example I can give you. But be sure that this is a very vast field of chemistry and it's not possible for anyone to cover everything in a span of a particular 30 minutes or 45 minutes or 1 hour. So my idea is to create an interest among you so that you can pursue your career in the particular field of research. So now Albert Einstein has said, if a mankind is to survive, it shall require a substantially new manner of thinking. That's important. The small word that Albert Einstein has told, it carries a lot of importance to it. For example, I can give you a very small funny story regarding this. You know perhaps the story of monkey and bananas. Monkey and banana. Monkey generally love bananas, that you know. They love banana, in fact. So scientists create an experiment. What they did, they took 4 or 5 monkeys. 5 monkeys they took, kept in a zoo. So whenever I'm not audible, please let me know. Okay? Okay, ji?
Okay, sir.
So scientists took 5 monkeys. They kept them in a zoo, enclosed cell. And thereafter what happens? They just kept some bananas, 5-10 bananas at some distance from them. Then what happens? I'm just correlating what this particularly what Albert Einstein has told and correlating it with a new manner of thinking that I'm correlating. Then I'll come to the subject matter. So what happens? The monkey, all of them try to run to eat the bananas, all the monkeys. So what happens whenever they try to run to eat the bananas, they drenched with the stream of water, and there is a mechanism to beat them, to dissuade them from not eating the bananas. They tried, all of them tried. So what happens? All of them get drenched in water. All of them get bitten. So what happens after some effort? All the 5 monkeys, they did not venture to go near the bananas, even if they loved to eat it, even if they felt hungry to eat it. So what happens? Scientists, what they did, they replaced one of the monkeys with a new monkey. Got my point? There are 5 monkeys. Now 4 monkeys are old monkeys who were bitten, drenched with water, and 1 monkey was new. That fellow do not know about any beating by somebody or drenched in water. So what happens? That new monkey tried to eat the banana. When he tried to approach the banana, all the 4 monkeys, rest 4 of the monkeys, they drag him and they beat that particular 1 monkey. Got my point? So after getting a thrust, beautiful beating by his fellow monkeys, not by the external. So what happened? That fellow deceived to get near the banana. So thereafter what the scientists did, they replaced another 1 monkey with a new monkey. Another 1 older monkey. Out of that 4 older monkey, again another 1 they replaced with a new monkey. Now what happens? The new monkey, that fellow never got any bitten or any shower of water. That fellow also tried to get near the bananas. The other 4 monkeys, they tried to beat him and dissuade him from getting near to the bananas. Now, in a process, all the 5 monkeys were replaced. None of them get bitten by any external force. None of them drenched in water. Now another one monkey was added to the stream, and that particular monkey tried to get near to the bananas. Again, these 5 monkeys, they try to beat that monkey not to get near that banana, because reason is that what you see, this new set of 5 monkey, they never got any beaten, never get drenched in water, but they still dissuade the new monkey to get near the banana. Reason, don't know. Reason, don't know. So the thing is that the moral of the story is that sometimes we try to follow the things what earlier is being done without knowing the reason for it, without understanding the thing. That traditional way of thinking we have to change. Then only if that manner, the thinking manner will change, then only we can substantially change our lifestyle. That is the first principle of life, first principle of science. Let it be green chemistry or adding chemistry, anything. Now, green chemistry, if you come to the core of the subject, the green chemistry, if you know the green chemistry, not it is nothing new now. It is also included in the courses of studies. University Grant Commission also gave a model syllabus regarding the green chemistry. It is a beautiful thing. So coming to the very basic textbook knowledge of the green chemistry, the background, you see, everywhere chemistry has improved the everyday lifestyle. It may be your drug, it may be a clean water, it may be food, it may be healthcare system, it may be use of appliances. Everywhere there is a use of chemistry. And chemistry, without chemistry, you cannot think of life, perhaps. Everything, even if you see the pen you are using, it is maybe the technology is involved, the material involved is chemistry. The garment you are using, this is also, if you see, this is textile chemistry. Everywhere some chemistry knowledge is there. So chemistry try to make the life system better. And in fact, it is making the life system more and more better nowadays. You can see the life expectancy now for any human being, even in India, it nearly approaches 65 something or 70 like that. Now, but thing is that such kind of advances, when we are going for the advances in chemistry, obviously industrial revolution takes place. Because industrial revolution, due to which our life system, the support system also enhances. But there are disasters associated with the such kind of advances also. And so far as chemistry is concerned, it is a much more difficult subject. And the chemistry people, they must understand that chemistry can create a life, chemistry can also destroy a life. So this is a series of events I have just taken from various sources. There are new things I have not included here. There are many new things are there. Even in, you see, from 1956, which is this Minamata Bay mercury poisoning, which is a very famous thing we know. Even in our Bhopal gas tragedy also, you know, it is also a chemical hazard. So the MIC, methyl isocyanate gas, which leaked from that Bhopal during that Bhopal gas tragedy, that killed a number of human beings. So industrial revolution, although it enhances the quality of life, it also spill over the environmental disasters. So these are few examples. More and more recent examples are there. You know all these things. So now, what is the consequences out of it? What is the consequences of this disaster? What is happening? This actually creates an understanding, or this creates an awareness regarding the environmental issues. So you see, due to this, all this problem, because we learn from the experience, due to this problem, what happens? The environmental law becomes very stringent. You see, nowadays in India also, no industry can come up unless until they get an environmental clearance, and that is important. Even I can tell you this, we are here in a new Central University of Jharkhand. Government has created many 14 new central universities, and all these central universities almost were situated in a barren land. no fertile land were given to them. Okay? No fertile lands were given to them. Why? The government does not want to block the fertile land for this construction purpose. That is good. That is good. Similarly, when you are here, when you are creating new buildings, when you are creating new system like your rain harvesting system, solar energy, these are, even when you are creating a building also, we are emphasizing upon the green environment. So the chemistry plays a vital role here. You see here also the construction material that you are using nowadays, the construction material you are using in our this building, new buildings, not the old construction material. Some waste material they recycled into the bricks, etc., and that can sustain longer duration, and they can also have adverse impact, minimum adverse impact upon the environment. So thing is that each and everywhere the knowledge of chemistry, if you see, I talk to them, how is the glass that they are using. This is also some kind of glasses that can able to absorb, not exactly reflect the sunlight. They can able to some kind of absorb the that is called the light to some extent. The harmful radiation they can able to absorb. Now, in order to improve the green way of working, even though now you see more and more e-filing systems are coming up. Of course, there are certain negative points are also associated with it. But thing is that what we think, what people are aware of, thing is that to go towards green in every aspect, let it be chemistry, let it be any other science. So minimum use of chemical, minimum use of lab, even if during the pandemic situation. What we did, we try to do the experiment in the online and show it to all the students. And when once again they join back, they can also try to do few experiments. So we emphasized upon the green chemistry. So this is how the life is tending towards the green. Green means all about why it is a green, not green, it is to mimic the nature. So now, coming to the field of chemistry, particularly because the chemistry fraternity is here, this particular awareness, these particular stringent laws in environmental, etc., they resulted in increase in testing of the chemical substances, understanding on the molecular basis of the hazard, understanding the global hazard, toxicological hazard, and to find out a way out of it. For example, you see, recently one of my friend who was working in an industry, he came to our department to deliver a lecture talk. He was a core industry personnel, and he was working in the alumina industry. And alumina was during the process of the production of the alumina, a lot of red mud is being generated. So he collaborated with us to use the red mud. Yes, red mud is a huge problem. Okay, but this is a byproduct, and without alumina, this aluminum industry, they have to produce a lot of red mud. So what is the use of red mud? So they devise some mechanism, some methodology, how the red mud is being used for this to make improve the fertility of the land. And red mud also people are also using to improve some catalyst to do certain other things. So this is how they try to promote the green chemistry. So this is even if it is a small attempt, but that was a nice attempt. Here they collaborated with us to supply us the red mud, and we are trying to convert the red mud in first step. Try to convert the red mud for a catalytic use, so that this red mud can be used as a catalyst. The red mud can be used as a fertilizer material. So you can see how the people are trying to promote the green chemistry. Now, the question is that why this promoting the green chemistry is important? It is nothing new to you. For example, you see in Odisha, you have many industries are there. And in industry, for example, fertilizer industries are there. In Paradip, there are fertilizer industries are there. And for this fertilizer industry, they producing ammonia, they are producing the sulfuric acid, they are producing the phosphoric acid, and there are many things they are producing. So in the production of the, for example, sulfuric acid, or the production of the ammonia, or production of the phosphoric acid, etc. Production of the sulfuric acid, for example, you see, when they are producing the sulfuric acid, fertilizer, this your sulfuric acid is a key ingredient. Without sulfuric acid production, you cannot go ahead for the other several steps of the production of the your fertilizers material. So what happens this during the production of the sulfuric acid, sulfur dioxide gases, sulfur trioxide gases, they are coming out of the stack or the chimney, you can say. So mechanism is there to reduce the amount of the sulfur dioxide, amount of the sulfur trioxide, etc. But still, those mechanisms are not sufficient. Their filters are there, absorption systems are there in place, but still some amount of the sulfur trioxide, some amount of sulfur dioxide, they are coming out of the stack. And even if it is small in ppm level or ppb level, they are causing the acid rain. They are causing so many adverse effects. This you can see in, if you go to the Paradip, here see, most there are two big industries are there. If you just happen to visit that place, you can see that how this coastal area, the fertile lands are being affected due to the this acid rain. So these compel us to think about the application of the green chemistry. Similarly, suppose in sulfuric acid, they are using the catalytic material. Without catalyst, the sulfuric acid cannot be produced. Nowadays, they are using the vanadium pentoxide catalyst. Now, the vanadium pentoxide catalyst, even if they are quite efficient in production of the sulfuric acid, but disposal of the vanadium pentoxide is a problem. So people are thinking about more using the polymeric catalyst, but there are problems also there. So this is a dynamic process. Scientists are working to improve the safety of the system. Scientists are trying to improve or add a new kind of material as well as technology to the industrial system, so that it will promote the green chemistry. That means it will be safe to the environment, and environmental safety is the most important, because we are human beings or the living organism. Unless the environment remains good, we cannot sustain. If oxygen is not available to us, we cannot inhale this carbon dioxide to live. So Dr. Fakir, am I audible? Is it okay?
Yes, audible. Audible.
Now, the thing is that, as I have told you, the green chemistry is also about the use of chemistry for the pollution of the prevention of the pollution, and seeking the replacement of the substitute of the alternative to the toxic compounds. Go through the this University Grant Commission one booklet upon the green chemistry. They have suggested many experiments in green chemistry, and there are good, nice books are there also in green chemistry. I think some noise are coming. Dr. Fakir, I think some background noise are.
Yes. Please mute some of the participants. They can't mute. Please mute it.
Okay. So this
Okay.
This particular green chemistry, if you whether you know, I'm sure you know it. This particular term was coined in 1990. Yes. This particular term is coined in 1990 by a scientist, Paul Anastas. So coming to the next slide. As your principal sir has told, just a few minutes before, this green chemistry is also known as the sustainable chemistry. Green chemistry is also known as the sustainable chemistry. That means it will remain there. It is there for the prevention of the pollution. It is there for the safety of the environment. And as a scientist, we have to think about the use of the green chemistry not only in our day-to-day life.
Please unmute.
Yes, am I audible?
Yes, sir. Yes.
Okay. Some background noise is still coming. No problem.
Okay. Oh, 2 or 3 students, they mute.
Okay. So now I will give you a few examples of the green chemistry that we used in our laboratory processes. Now, coming to the little bit more basic of the green chemistry. You see, I've given some examples of the various chemicals that we are used to face in the chemistry laboratory, like acetone. You see, not this. Still, I think Dr. Fakir, I think some noise is coming continuously.
I am trying. I am trying. So one student, he is not. Okay, you please continue. Continue.
Okay. So here I have given few examples of the chemicals as well as the systems that we are facing in the chemistry laboratory. For example, you see here the acetone. Acetone just one example. Not only acetone, even you see any amine compound, etc., that you are using in the chemistry laboratory, they're all carcinogenic as well, and majority of them are flammable. Not majority, almost all of them are flammable in nature. And during the synthesis process, during the preparation process, even in the chemistry lab, let it be a +2 chemistry lab or the BSc chemistry lab, you will see, you will encounter the high pressure steam, then temperature, all these things. And these are potential hazard in a chemistry laboratory. So can we think about replacing? I think Dr. Fakir, still some noises are coming. Hello, Dr. Fakir. Dr. Fakir, should I continue? Hello, Dr. Fakir. What happens? They are detached. Dr. Fakir, am I audible? Dr. Fakir, am I audible to all of the audience?
Yes, sir.
Yes, sir.
Should I continue?
Yes.
I thought there is some internet disruption at your end. Anyway, now come to the chemical industry. You see, so far as the process of the chemical industry is concerned, there is a feed chemical process where the energy is being spent. There will be emission of gases, etc. A final product will come out. In addition to a byproduct may be coming out. So this is a process, normal process in a chemical industry. And if you see all these chemical processes, the energy is an ingredient here. The emission process is an ingredient here. The product himself is an ingredient here. The byproduct itself is an ingredient here. So everywhere you'll see the energy is a expensive processes. And what happens, whether we can think about the minimization of the energy, whether we can think about the minimization of the emission, whether we can think of the minimization of the byproducts. So all this lead to the application of the green chemistry. Now coming to the next slide. In an industrial processes, these are the things that normally happens. Air emission happen, water pollution happens, solid waste happens, and so many gases, etc. They also comes out. So the green chemistry is a process by which we can try to any step in which we can try to reduce the all these things. Let it be air emission, let it be atom minimization, let it be water pollution, let it be solid waste management. Everywhere there is a application of the principle of the green chemistry. There are 12 principles of the green chemistry, and these 12 principles of the green chemistry, I can tell you here. This is the scientist that I have told you, Paul Anatas, who thought of the application of the green chemistry and regarded as the father of the green chemistry. And now there are 12. These are the, you see, the green chemistry is all about all these things based upon the 12 different principles. Okay, so atom economy, less hazardous, safer solvent, energy efficiency, renewable materials, catalysis, reduction of the step, and waste prevention. All this in an ideal chemical synthesis process, everywhere you can apply the principle of the green chemistry. Okay, so now coming to the that is called your 12 principle of the green chemistry. There are 12 principle of the green chemistry, and anything, these things you can get from the textbook knowledge also. A textbook all fed with all these things. There is a environmental thinking, there is a economic thinking. Environmental thinking, for example, when you are coming out to the atom economy. Okay, so environmental thinking is that whether we can reduce the byproduct so that the material that we have used, 100% of the product material will come from the feed material. But economic thinking is that incorporate the total values of the material. Similarly, when we are talking about the reduction, environmentally we are thinking about whether we can use less amount of the solvent. But when we are coming to the economical thinking, what is the use of the whether we can use the less energy, whether we can thought about the higher output. Similarly, for example, energy reduction. Environmental thinking, how this energy can be used. But here the economical thinking, how the minimum amount of the money can be spent in the production of the energy. So all these things, there is this is the research and development philosophy. When you're talking about the green chemistry, there is of course environmental thinking, but of course there is also a economic thinking is also there. Now, it is famously said that in a chemical process, ideally we should not produce any waste, but it is just an ideal process. Now, here I have given some examples of the chemical processes. For example, you see this is just a aldehyde with an amine compound. Production of a skip base. This particular chemistry people, I have taken some examples of the chemistry here. You see, in chemistry laboratory, you are thinking about the preparation of the skip base, a very simple chemical, simple material we are preparing. Okay, so this particular skip base, how you are preparing? You are taking a amine compound, and amine compounds are very toxic in nature. You are taking a aldehyde compound. Okay, it is of course toxic. Then you are taking a solvent. You are doing the condensation reaction because there is a water molecule need to be eliminated out. This H2O. Okay, this H2O molecule is need to be eliminated out. Here you are using some kind of catalyst maybe. Okay, acidic catalyst for the removal of the water. So after all, it produces a skip base. Now, can we think about production of the skip base by a simple solventless reaction process? For example, can we grind material A with the material B? Can we grind the material A with the material B to give you a material C, which is having a quantitative yield and no byproduct is here? And of course, we will get a material of the purity. So this is an example, but it is possible. If you see the University Grant Commission green chemistry book, this particular example is there. So this particular synthesis in your graduation classes also, you can adopt this particular synthesis process. This is an example of the green chemistry, application of the green chemistry. So now coming to the next slide, you see, in energy requirement, heating is there, cooling is there, stirring is there, distillation is there. compression is there, pumping is there, separation process is there, and all this require energy. That is the electricity they are requiring. And electricity from where we are getting? Electricity we are getting from the burning the coal. And this burning of the coal ultimately this lead to the deforestation and ultimately lead to the global warming. So nowadays, can we think about the using the biodiesel? Fuel we can get from the plants. So this is how a green chemistry is being implemented in laboratory as well as in our thinking process. This is just an example to, there are many more examples are there. In our laboratory, we are producing the biodiesel using a heterogeneous catalysis process and a homogeneous catalysis process. And homogeneous catalysis process is a known process where quantitative yield of the material is too high. But there is a problem is that recovery of the catalyst is a difficult process. So we are promoting the development of the new heterogeneous catalysis. Even if there is a little bit compromise in the production process, but still the heterogeneous catalysts are recoverable, reusable, and this promotes a green chemistry. Now, however, there are some barriers to the. So there are some, of course, some barriers to adopting of the greener technology.
मोटे सिंगड़ा खाली जाने दिलो सिंगड़ा तीटा मिठा उठा ने सारन को रूम रे पांच जन भाई ने 10टा सिंगड़ा 5टा मिठा सिंगड़ा आने के से एका दे दे आसियो आईक्यूएसी रे दे देबो ऊपर प्रिंसिपल को रूम दे देबो सेटा ओके मनो सर रे दे दे.
Now, Dr. Fakir, should I continue?
Yes, sir.
So there are some barriers for adopting the green chemistry or green technology, of course. And one of the most important thing is that the difficult to obtain the research and development funding. And the second thing is that if you see, there are so many points I have listed here, but out of so many points, few points I can emphasize upon. That is the difficulty in getting a R&D funding. Sometimes you require, when you are trying something, you require more and more research and development funding. And the second thing is that getting the data is most important. And third thing is that a culture to gear up to the that is called you have to imbibe a culture of working in a green chemistry. So these things are, there are a lot of things I have listed here. So few of the things that I have explained, that the green chemistry, even if we are thinking of implementation of all these things in chemistry, let it be chemistry laboratory, let it be in the chemical industry, but we have to develop a culture. You have to think, we have to develop a mindset to apply the green chemistry in our day-to-day processes. Now, I will give you some examples. Some examples I'll give you. That is the application of the green chemistry. One example I have given you regarding the synthesis of the material. That is the synthesis of the that is skip-based compound. How the green chemistry principle can help us in reduction of the solvent, reduction of the heating process, etc. in production of the that is called the skip-based. And this particular thing you can also do in your BSc chemistry lab itself. Now, more examples are there. Microwave techniques, starting from the microwave technique, starting from the stirring process, heating process, everywhere this can be applied substantially. So now, for example, I'll give you, there is a conventional heating. You take an example of the conventional heating versus the alternative source of energy. What happens in chemistry laboratory? You are using a Bunsen burner for heating everything. You are using a oil bath. You are using a heating mantle. These are all requiring a lot of energy. Electricity also required. But can we think about some alternative source of energy, like using the sunlight or the ultraviolet visible light, using the ultrasound, using the microwave technique for synthesis? All these things, for example, many, as my friend Fakir has told, I did some research in the that is called a polymer chemistry, leading to some green chemistry processes also. Here, when we are synthesizing the polymers, polymer synthesis is a typically very difficult process. We are using a lot of chemicals, a lot of energy, so many things are there. But thing is that when the product comes out, sometimes we are not able to get 99% pure product. So can we think about using the ultraviolet light in a in a process where UV visible light can be useful in the synthesis process. There, the thing is that you are minimizing the external heat energy, but simultaneously you are getting 99.9% pure product. That is what is important. Nowadays, people are using the microwave technique also many chemical synthesis process. If you go through the, as I have told you repeatedly, if you go through the graduation chemistry book, we'll see a lot of chemistry examples are there. Okay. Similarly, the ultrasound technique also many small synthesis process we can use can be used in the ultrasound synthesis process. For example, I can give you one example where I have synthesized a polymer. As I have told you, the nature is the best example of the green chemistry. Whatever the nature produces, it is only through the green chemistry processes. Okay, the human being that you have produced, you are also a product of the green chemistry. We are living being. After death, everything will be mixed up with the environment. There is no residue is left. The thing is polluting the atmosphere. You can see. When we, for example, in the process of during my biomaterial synthesis, I was asked by my guide or the supervisor to prepare some blood compatible material. I'm giving you just one example of the how I use the principle of the green chemistry in my research life. So I was synthesizing some kind of blood compatible polymer, and you know polymeric material synthesis is a very difficult thing. Okay, so what happens when I synthesized, I could not able to succeed because biomaterial synthesis is a very difficult process. It requires the purity. Okay, because that material has to be intended to apply inside the body itself. Okay, so there is no compromise over the purity of the material. So what my guide told me, what my supervisor told me, that you mimic the nature. For example, when I'm preparing a that is called a blood compatible polymer, any material, if you keep the blood over it, the blood will clot. So I had to devise a methodology where the material over a material, the blood should not clot at all. Okay, so that material development, what my guide told me, that you mimic the nature. So what I told, how inside the body is flowing, but there is no clotting of the blood. That mechanism I try to understand. How inside your vein, inside your, for example, artery, the blood is flowing, but there is no clotting mechanism inside the blood. So I have to understand what is the mechanism, what kind of chemical molecules are present in the artery or the veins which prevent the clotting of the blood. So that mechanism I applied in synthesis of my polymeric material. This is one example where I applied the principle of the green chemistry in taking a small step in promoting the green chemistry. Similarly, when you are preparing a material, majority of the chemistry material, they are prepared in the various toxic solvent. Let it be methanol, ethanol, DMSO, DMF, THF, so many, any chemicals you ask, all chemicals are more or less, they're toxic or hazardous in nature. So what happens? We try to prepare, whether it can be prepared in a water is abundantly available, water is less, not at all toxic to us. So how can? So my supervisor told me, can you prepare some kind of material? I tried, and after 2.5 years of my effort, I could able to prepare 1 or 2 materials which can be prepared in the water. Those polymeric materials prepared in the water, and those are also biocompatible polymeric material. And I published that paper, of course, in a very good journal. So this is where we are applying in a small step the knowledge of the green chemistry in our research processes, in our experimental processes. All about what we are. My idea is, my suggestion regarding the green chemistry is that see the nature, and there is no great scientist than the nature itself. I'll give some more examples, of course, that I have told you. In a alternative energy sources, I have told you. Similarly, alternative media for the reaction process. Nowadays, people are using the supercritical fluids instead of the conventional fluids. Ionic liquids people are using. Water example already have given. Polyethylene glycol is also one example which can be used as which can substitute a conventional toxic solvent. These are examples, and I have given examples where the water is being used. Similarly, nowadays many people are using for the synthesis process, and these are all promotes the green synthesis. Now, this is the mechanism of the microwaves heating. As I have told you here, the alternative source of energy, microwave, ultrasound, sunlight, electrochemical. So one example, all examples can be given. Just one example I have here. The mechanism of the microwave heating. This is a textbook knowledge, of course. Okay, this is a dipolar oscillation and this is a ionic conduction. Okay, you can get it in the text, but I'm not going detail into it because of the paucity of time. So you see here, I have given one example of how this chemistry is also can be done inside the microwave oven. Many chemical synthesis you will get inside a microwave. In our laboratory also we are synthesizing this many that is called product in the using the microwave oven itself. Okay. Now,
Professor Day,
yes,
screen sharing, is there any problem in sharing of the screen? Only the first slide is seen.
Is it visible to you now?
It is visible, but the first slide is shown. What about the other slides? I think there is a problem.
The slide is moving or not moving?
Moving. No, not moving.
Please see.
No. It is the first slide which is shown earlier.
Is it now moving?
No.
Is it okay? No.
No.
Let's check it. But it is moving in my screen.
Okay. Here it is not possible. Still then, okay, you continue.
No. Please see. Is there any? But I think maybe some internet issue from that side.
Yeah, that might be the case here.
No, because it is moving. It is
Okay,
here.
please. Yes. Yeah, okay, you continue.
I can share the slide. Okay.
No, sir, please. Slide is not moving at all.
Okay, 1 second. Should I share the slide?
Yes. You just share the slides again, sir.
Can you see?
No, sir.
No, the first slide is there. It is not moving at all.
Just a minute.
Okay. Oh, yes. It has come.
I think.
Okay.
Now it is okay?
Yes. Okay.
So now
Okay, sir.
You see, please, is it visible now?
Yes, it is visible. Yes.
I think some internet issue.
Now it is fine, sir. Okay.
So I have given some examples of the alternative energy sources, microwave, ultrasound, sunlight, electrochemicals, and some reaction medium, as I have told you, like supercritical fluid, ionic liquid, water, polyethylene glycol, solvent. All these things are example of the alternative source of energy and the alternative media. So this promotes the green synthesis process. Now, this is the mechanism of the microwave heating. I'm not going to detail all these things. And this is the microwave oven where we are using a lot for our chemistry also. A lot of synthesis, if you refer to the University Grant Commission book, it's a small book is there, very less costly. Okay, it is available easily. Just I suggest that the chemistry faculty member just bring that book and read it. And whatever is possible, whether we can incorporate few experiment, may not be all the experiment, few experiment can we incorporate in our graduation chemistry or +2 chemistry, that is most important. Now, coming to the some of the benefit of the, for example, microwave synthesis process, which is also known as the microwave assisted reaction. That is the faster reaction process, higher yield. I'll give you some example where we have synthesized few compounds using the microwave synthesis process. It leads to the faster reaction, it leads to the higher yield. Okay, and there is an absolute control over the reaction parameters, and there is a selective heating, activation of the catalyst. So many things are there. It is an energy efficient process. Rapid energy transfer happens in the process. And if you make it automation, then also a lot of this combinatorial chemistry process can also be done using the same microwave synthesis process. Okay. Now I'll give you some example that we have done in our laboratory. So this is one example. Of course, these are also, of course, the research thing little bit. So various faculty members that did research, and their examples I have taken. So you see there is this one in amine compound and this is a bromo compound, dibromo compound. They produce this particular material for use. Now you see here the reaction time conventional, if you see, if you use the conventional process in 0.33 conversion is 0, 1.0 to 26 conversion. If you reaction this, if you heat it in 24 hours reaction time, the percentage of the conversion is only 63%, more or less. But if you are using the microwave processes, this much of energy is spent, almost 95% percentage of conversion is there. This is one the research output I have shown here. Similarly, another 1-2 examples are there. So you see, similarly, alkylation reaction. In alkylation reaction, you see, for example, this is an example of an alkylation reaction, and here the conventional condition, they promotes use of all these chemicals here, but only the conversion percentage is only 50%, not more than that. But when you are using the microwave condition, this is a within a span of 5 minutes, we are getting almost 80 to 90% of conversion, and it is a clean conversion process. This is an alkylation reaction. These are all research thing, of course. People are research scholars or the faculty members are done, and their examples I am citing here with their permission, of course. Okay. So in our research laboratory, we are doing all these things. Similarly, for example, milder phthalimide deprotection reaction. This is a very known reaction to all of you in the graduation classes. Okay. And the conventional process, conventional conditions, as you know, these are very harsh conditions. Refluxing with excess hydrogen amount, reflux for 48 hours in 6 molar sodium hydroxide, all these things are there. Whereas the microwave assisted reaction is a faster process and milder process, where you are almost able to achieve 70% of the conversion, only 2 equivalent amount of the sodium hydroxide in water. That is what is the novelty of this particular chemical reaction, or using of the green synthesis or green processes in chemistry synthesis. Now, come to there is a particular event. It is so much popular that a particular solvent-free organic synthesis journal is also there. Many of the, you can see that this, if you want to adapt some of the chemical reaction, you want to adapt some of the chemical processes in your laboratory things, you can refer to this book, this particular book, which is a very nice book. We used to refer it. Okay, it is also available in our library. If you want, we can also share it with you. Okay, and this is of course a particular book which highlight upon the solvent-free organic synthesis. Okay, and of course a Japanese faculty member, they wrote these books. Okay, so the idea is to gain an interest upon the particular subject by the faculty member as well as our students. That is what important. Now, in solvent-free organic synthesis, what is the advantage out of it? This is a fast reaction kinetics happens. It is a clean and efficient synthesis process, and of course, it is economic and has an environmental impact. That means it is supporting the environmental managing processes. And of course, the best solvent is that use no solvents. That's most important, but it's not practically possible always. Okay. Now, some more example I am giving you. Okay, example of the solvent-free organic synthesis process. The Bayer-Villager oxidation reaction, all of you know. All of you are reading in the organic synthesis process. Okay, and you can refer to this particular Perkin transaction book. And here, this particular Bayer-Villager, and this is a reaction taken from the chemical communication. You can see that this particular reaction can be done in a solvent-less condition also. Okay, this and particular, you can achieve almost 70 to 80% of the yield, and without any formation of the much more byproduct. Okay, so in this Bayer-Villager oxidation reaction process, it conventionally you are reading it in your graduation classes, post-graduation classes also. So with these few words, because actually I have to attend one meeting with Honorable Vice Chancellor sir, so please allow me to stop it here. And if in case there is some question, I am ready to accept the question. Fakir, Dr. Fakir?
Sir, the name of the book, please.
Okay, I'll share this slide to Fakir. Don't worry, Doctor. He is my this particular I'm giving you this. Yes, please write down. You can search in the Google also, you will get this book. There is no problem. Solvent-free organic synthesis. Just give it in the Google, you just write it and you will get the whole book. There is no problem. This is really.
Thank you.
So, any question? I am ready to, of course, take up. Dr. Fakir? Yes. So, Dr. Fakir, am I audible? Hello?
Please see the chart. One student has given a
Please.
question.
Please.
See the chart, sir. One student has given a question.
Yes. Okay.
See the chart, sir.
Yes. What is the main issues of the green chemistry in the world? Very good question. And very, you can say, broad question for me. The main issue is that our mindset to accept. Our mindset is to accept, and to mindset to the important thing is that to innovate. In chemistry, so far as chemistry is concerned, we have to innovate, we have to do innovation, new chemical reactions that can happen in a greener way, following the greener path. I already told you that how I have adopted a small, that is called a step to changes the production of the my material. Just a very small step also they can promote the green chemistry. And the other issues regarding the green chemistry is that lack of information, lack of knowledge, and sharing of the knowledge, and research funding is more and more it is required for the promoting the green chemistry. Our chemistry, starting from our +2 chemistry laboratory, ending in the postgraduate or PhD chemistry laboratory, or whatever we are doing, is there any scope of incorporating the green chemistry? That is what is most important. I think I've answered your question. Yes. So any other question? So, Dr. Fakir, should I stop it here?
Nice presentation, sir. Thank you, sir.
Okay, so should I stop it here?
Hello.
Yes. My presentation is over. Okay.
Very nice presentation, sir. So all our best wishes to you, sir.
Thank you.
Okay. So at the end, I request IQAC Pattamundai College, Pattamundai to give a formal vote of thanks. Dr. Pradhan.
Hello. Am I? Hello. Hello. Respected Professor RK De of Central University, Jharkhand. Lastly, my role is with a formal vote of thanks to all the participants. First of all, I give a very good, warm, heartfelt thank to Professor RK De, who is a well-known figure not only in Odisha but also in the chemistry arena of whole India. I sincerely thank on behalf of Pattamundai College and also from the IQAC and Department of Chemistry Pattamundai College to Professor De, and I wish him all success in his future life and also wish best of luck in his future career. Secondly, I must thank the principal of the institution, Professor Prabhakar Raut, who has done his bit in providing the opportunity to organize such type of webinar at Pattamundai College. And next, I must thank HOD of the department, Dr. Dushasan Parida, who is constantly in touch with us and coordinating the whole webinar organization process. And then I must thank Professor Dr. FC Pradhan, convener of this webinar and architect of the whole webinar process and organizing such a beautiful webinar on green chemistry. And next, I must thank the participants, particularly the participants from different colleges from inside Odisha and outside Odisha, and researchers, students who have participated in the webinar and got a lot of information from Professor RK De regarding the development, recent development and advances in green chemistry. Also, he has given some beautiful example from his research life, which will be helpful to the students in the examination and in their future research work. And lastly, I thanks all those who are present in the webinar, and thank you all. Thank you.
Okay, many thanks, Professor De. Webinar ended now.
ସମସ୍ତଙ୍କୁ କହିଥିଲେ ଫଟୋଟା ସ୍କ୍ରିନଶଟ ନେଇକି ସମସ୍ତେ ଫଟୋ ଅନ୍ କରନ୍ତୁ ଇଏ ହଁ ରେକର୍ଡିଂଟା ଆସୁଛି ସେ ଇଏଟା ହେଇଯାଇଛି ରେକର୍ଡିଂଟା ଅନ୍ କରିଦେଲେ ସ୍କ୍ରିନଶଟଟା ଗୋଟେ ସମସ୍ତଙ୍କର ହଁ ସେଇଟା जो स्क्रीनशॉट जो ये गुड़ा पठाओनी फोटो गुड़ा स्क्रीनशॉट गुड़ा को केमिति एठी आनी हबो फोटोटा दबा पे हबो हां सेटा गुड़ा सब जल्दी बना इतने बड़ा कौन अब ओपन करें देखो शेयर से सेंड करो मेल दे शेयर उड़ा दे शेयर उड़ा दे ତମ ମେଲ ପଠାନ ହଁ 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 ଯାଉ କାଟ ଦो ହଁ ସେଥିପାଇଁ ସେ ଆସି ସେଣ୍ଡ ମେଲ ଓ ଏଇଠି ଅଛି ତୁ ଚାରିଟା ଆସିଗଲା ପାଞ୍ଚଟା ନେଟୱାର୍କ କଣ ୱାଇଫାଇ ତ ଏଠି ଅଛି ମଝିରେ ଠିକ ଚାଲିଥିଲା ଲାଷ୍ଟ
କଣ କହିବେନି
ये पाई दे हाँ 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 ताको से करनी पठेगा था मैं पठेली बा व्हाट्सएप को से भी अपन मेल भी सेंड करिए एटी डाउनलोड कर लो तुम एकदम बंद कर दे सिलेक्ट होने से ସେଥିରେ ଦଉନି ବୁକ୍ ନା ଫରୱାର୍ଡ କରିଦେଲେ ସେ एंड हाँ हाँ এইটা মেল ଅଛି মেଲ ରୁ ଆମେ WhatsApp କୁ ଚାହୁଁଛୁ ଏ କରିବା ପାଇଁ ଟିକେ କର ହଉଛି ମୁଭ ଟୁ କଲେ ତ ସେ ମେଲ ରେ ଆସିବ এটা ছিল তথ্য বলতে কোন জানি ये तो सुबह से जी तो दियो ना ना ବଡ କରିଦେଲେ ଯେ ମୁଁ ତାକୁ ଇଏ କଲେ
ଆପଣଙ୍କ ଏଇ
ଆଚ୍ଛା ତାକୁ ଟିକେ କହିଦେବ ସେ ଯୋଉ ମ୍ୟାଟେରିଆଲ ଟା ପଠେଇଦେବେ ଦେଲେ ଏଇଟାର ଆମର ଯୋଉଟା ଆମର କଣ ସେଟା ମିଟିଂ ସିଡ୍ୟୁଲ ଟା ହେଇଥିଲା ସେଇଟାର ଗୋଟେ କପି କାଢିଦେଲେ ଦିଟା କପି କାଢିଦେଲେ ଦିଟା ଇଏ କରେଇଦବ ସେଠି ଆମର 2000 ଟଙ୍କା ଅଛି ତାଙ୍କୁ 1000 ଟଙ୍କା ପଠେଇଦବ ସାଙ୍ଗେ ସାଙ୍ଗେ କାଲି ଆଡକୁ ଇଏ କରିଦେଲେ ତାଙ୍କ ପଇସା ଟା ନେଇ ଆସିବ ନା ମୁଁ ସେଠି ଗୋଟେ ସିଙ୍ଗଡା ଖାଇଥିଲି ଆଉ ଖାଇନି କଣ ଖାଇଥିଲି
ଆମେ ଯାହା କହିଲୁ ତାକୁ
ଏଇଟା ହେଲା ଭିଡିଓ
ମାରି ଦେଖିଆ
Eh,